I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today in this video, we are going to know about the method of variation of parameters. This is the one of the important method to solve the linear differential equation to find the complete solution or general solution of a linear differential equation. So what is the procedure? How we can solve by using this method? We are going to see now. So first of all, what is the method of variation of parameters for finding particular integral? We are going to see here. Method of variation of parameters enables us to find the solution of second and higher order differential equations with constant coefficients as well as variable coefficients. Here we can solve second order equation also and higher order equation also by using the method of variation of parameters. So here in this method particularly we are going to find the particular integral. By using this method, what we are finding? We are going to find particular integral. So already we know what is the solution of the given differential equation is for the non-homogeneous complementary function and particular integral. So procedure for the complementary function is as it is. There is no change in the complementary function. Already we discussed in the previous videos about this non-homogeneous differential equation. So for the homogeneous also, non-homogeneous also, finding the complementary function procedure is as it is. So here change will be in the particular integral only. Particular integral we are having different methods based on the q of x value. So already we know what is the general form of the given equation or differential equation. F of d into y equal to q of x. So by using the f of d we are going to find the complementary function. By using the q of x we are going to find the particular integral. So together this value is complete solution or general solution of the given linear differential equation. So here for the particular integral, we are having the different methods. It depends on the value of q of x. So already we discussed that. So if you are having q of x is e power ax, we are following the method 1. So for the q of x is sin ax or cos ax, then we are following the method 2. And for the third one, so if you are having x power k or x power m or x power n, we are following the method 3. The last one is if you are having e power ax into v. That means in place of e, we may have e power ax already we are having. So in place of e, we may have sin ax also, cos ax also, otherwise x power k or x power m or x power n also. Then together these values, then we are going to follow the method 4. So after this method 4, method 1, method 2, so we are having one more method, that is variation of parameters. So here we are going to use variation of parameters by using to calculate the particular integral. So what is the working rule for this method of variation of parameters? We are going to see here. So here we are considering the second order linear differential equation. So already we discussed we can calculate particular integral for the second order also, for the higher order differential equation also. So we can calculate for the second order and we can extend this one to the higher order also. First of all, just I am telling about the second order. You can observe here. Consider the second order linear differential equation. What is the second order linear differential equation? D square y by dx square plus p into dy by dx plus qy equal to f of x. So in this place we may have q of x also. So here in some notations we are showing here f of x, in some notations we are showing here q of x. So this is the second order linear differential equation. So based on this, what is the first step we have to do? We have to find the complementary function. What is the complementary function? Already we know. So complementary function is some arbitrary constant into e power ax. So that is here based on the root. So m1x, c2 into e power m2x. For the second order, we are going to get m1 and m2. That means two roots. So this is the complementary function. So in place of e power m1x, e power m2x, we are showing here a y1 and y2. So after here, what is the y1 and y2 are? Y1 and y2 are the linear independent solutions of equation 1. What is the equation 1? Already we told you, this is the second order linear differential equation. So here, what is the next value we are going to find here is calculate the W value, Wronskian value. So what is the Wronskian value? W equal to delta of y1, y2 and y1 dash and y2 dash. In some notation we are going to see here u and v also. In place of y1 we are taking u and in place of y2 we are taking v. So then u, v and u dash, v dash. So these both are same. So in some notations we are showing here the solutions with the y1 and y2. Here in some notations we are showing with the u and v. So what are the y1 and y2 we can see here. So this is the Wronskian value. So Wronskian value of y1 and y2, otherwise Wronskian value of u and v. So after calculating Wronskian value, what we have to do? So in the third step we are going to calculate the value of constants and constants. So here we are observing u1 equal to calculate u1 we are having the formula integral y2 f of x by w. So what is the w? W is nothing but the Wronskian value. And if you want u2 value, u2 is integral. By using y1 we are calculating u2. By using y2 we are calculating u1 here. So u2 equal to integral y1 f of x by w into dx. In some notations we are showing here a equal to minus integral v into f of x, nothing but q of x, both are same. So v into q of x by w into dx and v equal to integral u into f of x or q of x by w into dx. These both values are same. So here we are denoting with u1 and u2, here we are denoting with a and b. So there is no difference. So we are using these formulas to calculate the constants. So after that, what is the particular integral? So after calculating u1 and u2, so here in place of c1, you are replacing u1. In place of c2, we are replacing u2. So then that is the particular integral. Otherwise, a into u plus b into v. This is the particular integral. So after this, what we are telling, what is the complete solution or general solution? Complete solution or general solution of given equation is CF and PI, and here together that value is complete solution or general solution. These are the steps, or this is the working rule we are going to use to solve the given equation by using the method of variation of parameters. Just I want to recall you the steps. First, we have to calculate the complementary function. So what is the complementary function? Complementary function y equal to c1 into some u, otherwise y1, and c2 into v, otherwise y2. So this is the complementary function. After calculating the complementary function, here we are going to know about what is u value and what is v value. So now based on this u and v, we are going to calculate the Wronskian value. What is the Wronskian value? u, v and u dash, v dash. So now after calculating Wronskian value, we can calculate the arbitrary constants. Here we'll assume the particular integral first in the third step. What we will assume here based on the complementary function? Here we are assuming particular integral is in place of c1 I am taking a u plus in place of c2 I am taking b into b. V into V. So here I am going to calculate. Already I know about the U and V here. So I got these two values from the complementary function. I should know about the V and V. So what is the A? A is the U1 here. So by using this formula I can calculate A value. By using this formula I can calculate the V value. So after that I can write the particular integral. After calculating A and B values, replacing here, I can get the final value, that is A into U plus B into V. That is the particular integral. After finding the particular integral, I can add with the complementary function to get the complete solution. So complete solution is here y equal to CF plus PI. So here So this is commonly used to solve the second order differential equation, and we can extend this one to the higher order also. So first we will go with one example to get the better clarity about this method. See the question. Solve the differential equation. What is the differential equation they given? That is d square y by dx square plus y equal to cosecant x. This is the given differential equation. So what they are asking, solve this differential equation by using the method of variation of parameters. Here we are going to follow the method of variation of parameters. So first of all, we are writing the given equation. The given equation is d square y by dx square plus y equal to cosecant x. This is the given differential equation. From this, I am going to write the operator form. This is already we know this in the previous videos. So what is the d value? D is d by dx. Here capital D square is d square by dx square. So from this we are going to write this value as d square y plus y equal to cosecant x. So now I can write this one as d square plus 1 into y equal to cosecant x. Now this is in the form of f of d into y is equal to q of x. Now I can identify the what is the f of d value. F of d value is d square plus 1 and q of x value is cosecant x. Q of x value is cosecant x. Now after identifying the f of d and q of x value. So what is the procedure for the method of variation of parameters? We have to see. The first step, what we are doing in the first step, we are going to find the complementary function. To find the complementary function, already we know the procedure. We need the auxiliary equation. What is the auxiliary equation? That is f of m is equal to 0. F of d is d square plus 1. What is the f of m value here? So in place of d, we are going to replace the m. So m square plus 1 is equal to 0. That implies what is the m square value? M square value is minus 1. So finally, I can get the value. This one is plus or minus I. So here, this is the m value. So based on the m values, we can write the complementary function. So complementary function equal to, here I can assume this one as 0 plus or minus I. That means this is equal to alpha plus or minus I beta. Alpha value is 0 and beta value is 1. So based on this, what is the complementary function? E power alpha x into C1 cos beta x plus C2 sin beta x. This is the complementary function for the complex roots. So here what is the alpha value? Alpha value is 0. So e power 0x C1 cos, what is the beta value? 1. So cos x plus C2 into sin x. So finally complementary function is equal to C1 cos x plus C2 sin x. This is the complementary function of the given equation. That is only you can observe here. So we can observe here, this is the operator form d square plus 1 into y equal to cosecant x. What is the auxiliary equation? Auxiliary equation is m square plus 1 equal to 0. So from that we are calculating m equal to plus or minus I. So based on that we are writing the complementary function, that is C1 cos x plus C2 sin x. So here by using this form we are assuming here y equal to, in place of C1 I am taking some a into cos x plus in place of C2 I am taking b sin x. So here cos x is the y1 and sin x is the y2. Otherwise you can take here this is equal to v and this is equal to u. Nothing but u equal to y1 or v equal to y2. So this is the first step completed. So after calculating the first step, what we are going to do? We are going to calculate the Wronskian value. What is the Wronskian value? W equal to y1 y2. Otherwise u1 u2 also you can write. So I am writing here u v u dash v dash. So what is the u value? U value is cos x and v value is sin x. So I am replacing here cos x and here sin x. And what is the u dash value? U dash equal to derivative of u. So derivative of cos x is minus sin x. And here v dash means derivative of v. So derivative of v is derivative of sin x is cos x. So here minus sin x, here cos x. We are going to find this debt value. What is the debt value? Here cross multiplication AD minus BC. So cos square x plus sin square x is equal to 1. So finally what I got here, W value or Raskin value is 1. So second step is completed. Now we are going to do the third one. So here y, what do we assume? A into cos x plus b into sin x. Now we are going to calculate A and B values, otherwise u1 and u2 values by using the formula. So what is the formula here? A equal to minus integral v into q of x by w. So minus integral, what is the b value? B value is sin x into q of x value is cosecant x. W value is 1 into dx. Now minus integral sin x into cosecant x is 1 by sin x into dx. Sin x will be cancelled. Finally minus integral dx is minus x. That is only we got here for the u1 or a value. So a value we got minus x here. Now we are going to find the b value. What is the formula for the b? Integral y1 or u. Here in place of y1 I am taking u. So u into q of x, u into q of x by w into dx. What is the u value? U value is cos x into cosecant x. Cosecant x by w value is 1 into dx. Now integral cos x into cosecant x is 1 by sin x into dx. Now sin x derivative is cos x. So now it is in the form of f dash of x by f of x dx. So here I can write this one as a log fx. What is the f of x here? Log sin x. I can write this one as a log x. So that's why here we are taking the log sin x. So b value is log sin x, a value is minus x. So now I got the values of a and b. I can replace here y equal to a into u plus b into v. What is the a value? Minus x cos x. U value is cos x plus b is log sin x into v value is sin x. So finally I can write this one as minus x cos x plus sin x into log sin x. This is the particular integral. Now already I calculated complementary function. Now I know the particular integral. So I can write the complete solution. You can observe this. So what I told you, that same thing we are having here. Particular integral equal to u1 y1 plus u2 y2. Otherwise a into u plus b into v. So what is the a value or u1 value? That is minus x. So minus x, u is cos x plus b value is, otherwise u2 value is log sin x. So log sin x into v value is sin x. This is our particular integral. Now we are going to write the complete solution. Complete solution is complementary function plus particular integral. Complementary function already we calculated, that is c1 cos x plus c2 sin x, and particular integral is minus x cos x plus sin x into log sin x. This is our complete solution or general solution of the given equation. So this is the way to calculate the particular integral by using the method of variation of parameters. So we will move with one more example here. Please observe clearly and you can learn this method very easily. So solve the differential equation. What is the differential equation? D square minus 2d plus 1 into y is equal to e power x. So we have to solve this equation using method of variation of parameters. So here also we are going to use the method of variation of parameters. What are the steps we are going to follow? First step, we have to write the how to find the complementary function. So after that we have to calculate the Wronskian value, that of u v or u dash v dash, the Wronskian value. After that we are going to find the a value and b value by using the formulas minus integral b into q of x by w into dx. For the b equal to integral u into q of x by w into dx. So now these two values we are going to find. So after finding the a and b values, we can write the particular integral based on the complementary function. These are the four steps we are going to follow here. First, see the solution. So first of all, we have to find the complementary function. For the complementary function, we should know about the f of t. What is the f of t here? D square minus 2d plus 1. So from this we can write the auxiliary equation. What is the auxiliary equation? So what is the auxiliary equation? Auxiliary equation is f of m equal to 0. That means in place of d we are going to replace here f of t is d square minus 2d plus 1. So from this we can write f of m value. So that is m square minus 2m plus 1. That is only we wrote here. So here m square minus 2m plus 1. So from this we are going to find the roots. So m square minus 2m. So this one I can write it as minus m plus 1 equal to 0. So from this I am writing. So take the m common. So this one m minus 1. Take minus 1 common. M minus 1 equal to 0. So here we are getting m minus 1 whole square. Otherwise, already we know a minus b whole square formula. Based on that also directly can write the m minus 1 whole square. So from this we are going to get m values are 1 comma 1. That is all we can observe here. M values we are getting here 1 comma 1. So here these two roots are equal and real. So what is the complementary function here? Complementary function equal to, here two roots are real and same. Then we can write c1 plus c2 into x into e power mx. So here based on this we are writing c1 plus c2 into x. Here m1 value is 1. So e power x. Now c1 into e power x plus c2 into x into e power x. Now I am writing this one as a c1 into a plus, sorry, here in place of c we are writing a. This is e power x u plus here b into x into e power x is b. Otherwise u equal to r, y1 equal to e power x, and b equal to y2 equal to x into e power x. You can use the notation u and v, otherwise y1 and y2 both are same. So here based on this we are writing y1 equal to e power x and y2 equal to x into e power x. Now we are assuming the particular integral. What is the particular integral? A into u plus b into v. So what is the u value? U value, otherwise y1 value is e power x and y2 or v is x into e power x. Now what is the third step we are going to do, and the second step we are going to do? So we have to calculate the Wronskian value. What is the Wronskian value? W equal to y1 y2 y1 dash y2 dash, otherwise u v and u dash v dash. So what is the u value? U value is e power x and v value is x into e power x. Here what is the u dash value? So u derivative is power x is e power x. What is the v dash value? Here we have to write the u into v formula. X into e power x is e power x plus e power x into x value is 1. So here u dash is e power x and v dash is x into e power x plus e power x. This is the value we are going to find here. Now see, this is the Wronskian value. So when you are doing the value here, we are getting here e power 2x. So we are getting e power x into e power x plus e power x minus x into e power x into e power x. Now, so x into e power 2x plus e power 2x minus x into e power 2x. These two values will be cancelled. Finally, what we are getting here? E power 2x. That is only we got here. So this is the Wronskian value. Wronskian value is e power 2x. So after getting the Ranskin value, what we have to find? We have to calculate the A and B values. What is the formula for A? A equal to, otherwise y1 equal to minus integral. Sorry, here. So here, this one is A equal to, otherwise u1 equal to minus integral v into Vr by 2, v into q of x by w into dx. This is the formula. So minus v value, r y2 value. So here, what is the v r y2? That is x into e power x. Asking value is, what is the q of x value? Q of x value is e power x by constant value is e power 2x into dx. So here e power 2x will be cancelled, minus integral x dx. This value is minus x squared by 2. This is the value of a. This is the value of a. So what is the value of p? P equal to, otherwise u2 equal to integral u into q of x by w into dx. So here integral u is nothing but y1. So e power x into e power x by e power 2x dx. So these two will be cancelled. So integral dx is equal to x. So this is the a value, this is the b value. That is only you can observe here. So u1 value, otherwise a value is a minus x squared by 2, and u2 value, otherwise b value is x. So after getting the a and b values, we can write the particular integral yp equal to r, pi equal to a into u plus b into v. So a into u value is e power x plus b into v value is x into e power x. So here what is the a value? Minus x square by 2 into e power x plus what is the b value? X into here, x into e power x. That is only we can observe here. Now see the same solution. So particular integral equal to a into u plus b into v. Otherwise u into v1 plus u2 into y2. So here the u1 value, otherwise v value minus x squared by 2 into e power x plus here x into e power x. So x into x is x squared. So after simplification we got the particular integral is x squared by 2 e power x. So already calculated complement function and particular integral. So we can write the complete solution or general solution, that is CF plus PI. CF value is already we calculated in the first step. So that is C1 plus C2x into e power x plus here particular integral is x squared by 2 into e power x. So this is the final solution. Otherwise this is the complete solution. Otherwise this is the general solution of the given equation. That is only we can observe here. See, this complete solution is y equal to CF plus PI. So finally y equal to, what is the complementary function? C1 plus C2x into e power x plus x squared by 2 into e power x. So this is our complete solution or general solution of the given equation. So this is the way to calculate the particular integral by using the variation of parameters. So see one more example here about the method of variation of parameters. Solve the differential equation, that is d square y by dx square plus 4y equal to x into sin x. Before we are having e power x, so now we are having x into sin 2x. What is the value for the q of x? There is no difference here. So same procedure we are going to follow. So first of all, we are going to write the complementary function based on the given equation. So f of d into y equal to q of x. So what is the f of d? F of d is d square plus 4. Now we need the auxiliary equation to calculate the complementary function. What is the auxiliary equation? M square plus 4 equal to 0. So from this I can write the complementary function. So for the m values I am getting plus or minus 12. So here m square equal to minus 4. So finally m equal to plus or minus 2i. That is what I can write this one as a 0 plus or minus 2i. So alpha plus I beta. So what is the complementary function? Yc equal to e power alpha x into c1 cos beta x plus c2 sin beta x. This is the formula for the complementary function. So based on that I am writing here e power alpha value is 0. So e power 0x c1 into beta value is 2. So cos 2x plus sin 2x. This is only we wrote here. So complementary function c1 cos 2x plus c2 sin 2x, because here e power 0 is 1. So now we are assuming the particular integral here. Particular integral equal to a into u plus b into v. Otherwise c1 into y1. In place of u we are taking y1, plus in place of v we are taking y2. So now what is the u and y1 value? U equal to or y1 equal to cos 2x and v or y2 equal to sin 2x. So what is the next step we have to do here? So here we have to take the Wronskian value. So Wronskian value is y1, y2, y1 dash, y2 dash. Otherwise, u, v and u dash, v dash. What is the u value here? Cos 2x. What is the v value here? Sin 2x. And derivative of u is, what is derivative of u? Derivative of cos is minus. So here we can write u dash equal to cos derivative is minus sin. So minus sin 2x into 2. And here v dash equal to cos 2x into 2 here. So we are writing u dash value is minus 2 into sin 2x and v dash value is 2 into cos 2x. So now we am calculating this one. 2 into cos square 2x plus here 2 into sin square 2x. So finally 2 into 1. This value is 2. So Wronskian value we got 2. So see the same thing. So here also we got Wronskian value is 2. So what is the need of the W value to calculate the A and B? Otherwise U1 and U2 we need the W value in the formula. So that's why first we calculated the Wronskian value. So what is the formula for that? First U1 equal to, otherwise A equal to minus integral y2 or v into q of x by w into dx. So here minus integral, what is the y2 value or p value here? That is sin 2x into q of x value is x into sin 2x by Wronskian value is 2 into dx. So here minus 1 by 2 is the constant taking out. Here x into sin square 2x. Here sin 2x, here sin 2x. So sin square 2x into dx. So in place of sin square 2x, I can write this one as a minus 1 by 2. 1 minus cos 4x by 2. So that's why I got one more 2. So x into 1 minus cos 4x. So here already I told you, when you are having the trigonometric formula, we can convert this one into the form of integral part by using the trigonometric formula. So here this one is, I am calculating minus 1 by 4 integral x into dx minus 1 by 4 integral cos 4x into dx. So based on that I am getting here x, here one more x is there. So finally integral x value is minus 1 by 4, integral x is x square by 2. So here next step 1 by 4 into x square by 2 and minus integral x into 1 by 4 also is there, x into cos 4x dx. That is u into v formula. So u integral v. So u is x, integral v is integral cos 4x is sin 4x by 4 minus 1 into here integral u v formula, u integral v minus integral u dash into integral v whole again dv. So this is the formula we are following here. So u dash is x dash, that value is 1. So this is the v1. So integral again v. So that value is integral cos 4x by 4. So finally cos 4x by 16 we got here. So finally we are getting minus x square by 8 here minus minus plus, here this minus minus plus x sine 4x by 16, and here also cos 4x by 64. This is the value of u1. Next u2, otherwise b value integral. Here integral u into f of x r q of x by w. Here integral. What is the u value? U value is cos 2x, and here b value, q of x value is x into sine 2x by 2 into dx. So 1 by 2 is the constant, taking out integral cos 2x into x sine 2x. So here I am having 1 by 2 x into cos 2x and sine 2x. So I can write this one as a 2 sin a cos b formula. So sine 2x I can write. So that's why I am taking one more 2 here. So this is becoming 1 by 2 integral x into sine, already 2x is there. So actually x is there, you can write sine 2x. Already 2x is there, you can write 4x. Sine 4x dx. So now 1 by 4 integral u into v formula u, that is x. Integral sine 4x is minus cos 4x by 4 minus integral u dash is 1, and here minus cos 4x by 4 into dx. What is the next step we can do here? 1 by 4. So 1 by 16. 4 4s are 16, right? So minus x into cos 4x. Here minus minus plus 1 by 4 is there. Here one more 1 by 4. So integral cos 4x is sine 4x by 4. So this is the value. This is the value we can observe here. Same thing we are going to see. So same thing, u into v formula. Here we are getting the value minus x cos 4x by 16 and sine 4x by 64. So now, based on this, we calculated u1 value and u2 value. I am replacing here. So y1 or u value is cos 2x into here a into u plus b into v. So u is nothing but u1, y1, v is nothing but y2, and here a value, this one is cos 2x, and this is the a value, minus x squared by 8 plus x sine 4x by 16 plus cos 4x by 64 plus here this value is sine 2x, so minus x cos 4x by 16 plus sine 4x by 64. So after simplifying this, we are getting here x by 16 into sine 4x cos 2x minus cos 4x sine 2x plus here 1 by 64 into cos 4x cos 2x plus sine 4x sine 2x. So here after simplification we are getting this value. So finally this is the particular integral. Now what is the complete solution or general solution? That is y equal to complementary function plus particular integral. So complementary function already calculated, that is c1 cos 2x plus c2 sin 2x, and we are replacing the particular integral also. X by 16 into sin 2x plus here cos 2x by 64 minus x square by 8 into cos 2x. This is our complete solution or general solution of the given equation. Here the simplification of these values will be depend on the q of x. So q of x value is simple, then we can get the particular integral a and b values also very easily. If you are having difficult terms or multiple terms, then we are getting some more lengthy and difficult simplification here. So that's why you have to check properly and when you are doing the simplification. I hope we get the better clarity about this method of variation of parameters. Just I want to recall the procedure of the method of variation of parameters. The first step, you have to find the complementary function. The second step, here you have to calculate the Wronskian value, that is the rate of y1, y2 and y1 dash, y2 dash. After calculating the Wronskian value, we have to calculate the A or u1 value, B or u2 value. So here we are having the formula, so minus integral y2 into q of x by w. Here integral y1 into q of x by w into dx. Here also dx. So after calculating a and b values, finally you can write the particular integral. So already complementary function calculated in the first step, particular integral calculated in the final step. So finally in the fifth step, What is the complete solution? That is CF plus PA. So this is the procedure. Otherwise, these are the steps we are following here in the method of variation of parameters. So for the more examples, you can refer these textbooks, Higher Engineering Mathematics written by V.S. Gravel, and a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal, and Higher Engineering Mathematics written by B.V. Ramana. So please take more examples, and please practice the problems for the method of variation of parameters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.